Today's lesson is all about oxidation numbers. Now, we have already done this before, so this is really a quick review. Remember, oxidation numbers are charges. In the past, we have looked at the periodic table, and on the top right corner of every element are given all the possible oxidation numbers. So just a quick review, anything in the first column, they all have one valence electron. They want to lose that one to become like a noble gas, so losing electrons, they will get a +1 charge. Second one, +2 charge. Here, +3 charge. Noble gases would have a 0 charge. Fluorine, chlorine, bromine groups, halogens would have a -1 charge. Oxygen group, -2, -3. And we had talked about how this group would be -4 or +4, depending on if it's a metal or a non-metal. Remember, metals can only have a positive charge. All the transition metals can have multiple possible charges. When we had talked about naming compounds, we had to look at what their charge was in order to figure out how to name them, what their charge was. Also, just so you know, on here it says selected oxidation states, meaning not everyone is on there. They are just a selected few. Most of the time on the regions, you're not gonna see anything that's not on the reference table. The only one exception is gonna be for oxygen, and we're gonna talk about that exception in just a second. So some basic rules for determining oxidation numbers. The simplest one, the first one, just like what we just talked about, group 1 has a +1 charge, so +1 oxidation number. Group 2 has a +2 charge, +2 oxidation state, and group 3A is +3. Those are all set. Again, those are they're again also given in the reference table, so no change from that. Rule number 2 is that the oxidation state of any uncombined element or a diatomic molecule is 0. So for example, in a reaction, if you see iron, well, it's unreacted by itself, it's neutral, so the oxidation state is going to be 0. If I have something like Cl2, it's diatomic, oxidation state is going to be 0. So any element that's not combined with another one, the charge or the oxidation state is going to be 0. Rule number 3 says the sum of oxidation numbers of all elements in a compound or ion is equal to the overall charge. So we'll start with something that's neutral. So let's say we have calcium chloride. Now we know that calcium can only have a +2 oxidation state. Chlorine, because it's an ionic compound, the only charge it can have is a -1. Those are your oxidation states, which we write above the compound. In order to add them up, since there are 2 chlorines, the total charge from chlorine you get is a -2. Calcium, there's only 1, so you get a +2. Because the whole thing is neutral, the charge has to add up to 0. Here's another example, H2O. Oxygen is always -2, so the total charge I get from oxygen is -2. Hydrogen, so I need to get a total charge from hydrogen of a +2. There's 2 of them, so hydrogen would have a +1 oxidation state. If I have a polyatomic ion, for example, I have NO3-. Now, in this case, all the charge of the entire thing needs to add up to a -1. Oxygen, we always know, is -2. There's 3 of them, so the total charge from oxygen is -6. It all has to add up to -1. So what does the oxidation state of nitrogen have to be so it all adds up to a -1? In this case, +5. So again, oxidation numbers are written above the formula. +5, their total charge must add up to their individual charges must add up to their overall charge. For covalent compounds, the more electronegative element has the negative oxidation number. So again, generally speaking, now this is a generality, but if I have SO2, just like for ionic compounds, the positive one is written first, the negative one is written next. Same thing for covalent compounds. Another way to tell is that the more electronegative element is going to is going to have the negative charge. So oxygen is more electronegative than sulfur, so oxygen is going to have the -2 charge, as usual. There's 2 of them, so -4. So in this case, sulfur must be +4. Now we said oxygen always has a -2 charge, except, and again, there are really 2 exceptions. One of them is if it's combined with OF2, or with fluorine. If I have OF2, fluorine is the most electronegative element, so it has to have the negative charge, and fluorine can only have a -1 oxidation state. So there's 2 fluorines, overall charge of -2, so oxygen is forced to be +2. The other exception for oxygen is with the peroxide ion. Now with peroxide ion, it's also given in your polyatomic ion list. Here's an example. I have H2O2. Again, oxygen is more electronegative, so that will of course be negative. Hydrogen will have to be the positive one. Hydrogen is always +1. There's only one exception, which we'll talk about in just a second. Hydrogen is +1, so the total charge from hydrogen would be +2. So the total charge from oxygen must be -2. The -2 comes from 2 oxygens. So each oxygen is going to have a -1 charge. So as far as oxygen goes, there are 2 possible oxidation states. It can have +2 or a -1, other than its standard -2 charge. 99% of the time, it's going to have a charge of -2, which you get right from the reference table. These 2 are always, there are always going to be questions on the regions about these 2, but these are the ones that are not given on the reference table. So you have to be able to figure it out. Any kind of peroxide ion, oxygen is -1. If it's combined with fluorine as an OF2, it's going to have a +2 charge. Last rule is for hydrogen. Hydrogen we said is always +1. Now on the reference table, if you look for hydrogen, the square for hydrogen, it does tell you it's either +1 or -1. Well, there's only one time when it can have a -1 charge. If it's combined with a group 1 metal. For example, if I have NaH, sodium, group 1 metal, has 1 valence electron, it can only have a +1 charge, so it forces hydrogen to have a -1 charge. Again, if you notice, if it's with a metal, metals always come first. Metals are always going to be positive. Hydrogen is a nonmetal. In this case, it would have the negative charge. Again, 99.9% of the time, hydrogen is +1. Only when it's combined with a group 1 metal will it actually have a -1 charge. So those are your 6 rules for assigning oxidation numbers. These 2, as you can see, 5 and 6, are about the exceptions to the rule for oxygen and hydrogen. 99% of the time, oxygen is going to be -2, hydrogen is going to be +1, but again, there are those few exceptions. Now we're going to try a worksheet in class to practice these. Until we do the worksheet, this is your assignment. I would like you to figure out the oxidation state of sulfur in each of these 3. Well, this is an element and these 2 are compounds. Good luck.